Good morning, Algebra 2 students. So really quickly, the log rules from yesterday is that if you're multiplying the log of two things, think multiply bases, so I add exponents. So we can split it up and you can add them as two separate logs. When you divide bases, you subtract exponents. So it's log of x minus log of y. And then when you have a power raised to a power, you multiply. So this becomes the y dropping out front times the log of x. All right. So those are your three rules. So up at the top here, I'm going to put notes 12-4, where what we are doing, we are evaluating logs, and then also talking about the log domain. So what are you allowed to plug in to a log? So a couple things. Let's talk about the calculator stuff. On the calculator, there's the log button, which if I bring my calculator over so you can see, that's this guy right here. So here's the 7. It's right next to the 7. That's your log button. That's called common log. This is the one that has log base 10. Right, and the reason it's called common log is just powers of 10 are pretty common. So 10 to the first, 10 to the second, 10 to the third. Those are all using a base of 10, right? The next one you're going to see is the button underneath it is the ln. In the last unit, we did like e to whatever in the PERT formula. So we did second ln. What ln stands for, this is specifically log base e, right? But it gets its own special name because it's such a commonly used log. So we call it ln or natural log. And no, I don't know why it's ln versus nl, but that's okay. All right. The last button that you have, now not everybody has this button on their calculator, but a lot of you do, right? You have to hit the math button, and then you're going to arrow up to choice A, and it's the log base, right? And what you're going to see when you go to that one is it's going to let you type in what's the base that you want, and then what's the number you're taking the log of. So I'm going to write that little note here. What's the base? And then in here goes what's the number. So on the calculator, let me quick show you that. Keep in mind, it's a video. You can stop, pause, rewatch anything you need to. Take advantage of that. All right. So on your calculator, if I go to math right here, there's math. I'm going to arrow up to A, and there's that log base right there. So when I hit it on my calculator, let me zoom in here so you guys can see a little better. Oops, that way. It's going to let me type in whatever base I want and let me type in whatever number I want, right? If your calculator does not have the log base, I will show you how to do this by the end of the lesson. So just hold tight, all right? So with that being said, all those logs you did yesterday at the start of the notes, you now could use that log base button to evaluate each one of those. So let me show you what I mean. So let's do some examples over here. All right. So first thing, if I ask you to calculate the log of 100, right? Since I didn't give a base on there, it means it's common log or log base 10. So on your calculator, you can just hit log 100, hit enter, and ta-da, there's your answer, 2. What I want you to keep reminding yourself is, why does that make sense? Why is 2 the answer? So if I over here do a little work, if I have log of 100, right, remind yourself that the base is 10. If I set this equal to some like generic x, how would we get rid of the log? We would exponentiate using a base of 10. So I would do 10 raised to the left side, 10 raise it to the right side, and this would cancel. And I would be looking at 100, equals 10 to what power? You guys know, 10 squared is equal to 100. So the log is always equal to the exponent right there. That's why it comes out as 2. Right? So what if I ask you to evaluate log of something like 56? All right, well, the calculator can handle it. We could estimate it, but let's talk about why the answer makes sense of what it does. So type it in. If we do log of 56, you're going to get some crazy decimal. If we just write it to a couple places, so like 1.748, and we'll just ... it to acknowledge that it keeps going. What I'd want you to think of is you're saying 10 to what power equals 56? Well, 56 isn't a power of 10. That's pretty, which is why you're getting a decimal answer. But think to yourself, 10 to the first power is 10. 10 to the second power is 100. So 10 to what power comes out as 56? That exponent has to be somewhere between 1 and 2, which makes sense that we ended up with this 1.748 and whatnot. And then could you test it? Sure. If I do 10 and I raise it to the 1.748, it's going to get me pretty close to 56. I rounded it, so this answer is going to be a smidge off, but 55.97 is pretty close to 56. Right? But that's what it means. You're finding the exponent that 10 is going to get raised to be able to produce that number. All right. With that being said, now I want to change up the base on you. What if we do log base 3 of 40? So what I want you to think of again, let's think of powers of the first is 3. 3 to the second is 9. 3 to the third, that's 27. When we hit 3 to the fourth, that would be 81. So if I'm looking for what power of 3 would give me 40, it's got to be somewhere in between 3 and 4, because 40 is in between 27 and 81. Right? So if we had to make like a guesstimate, I don't know, probably a little closer to 3 than the 4, because 40 is closer to 27 than it is to 81. So I would say that this is somewhere between 3 and 4. And now, how do we actually, excuse me, how do we actually do it? Here's where you can do it with the log base button. All right. So if you grab your calculator and we type in log base 3, so I'm run those steps again. You're going to go over here and you're going to go to math and arrow up to log base. And then you can type in that base of 3. Let me zoom in so you can see it better. And then of 40, right? Hit enter. We get 3.3577 and it keeps going. Is if you have the log base button, easy peasy, that number 3.35, it's exactly somewhere between 3 and 4, probably a little closer to 3. So that looks awesome. If though you don't have the log base button, let's talk about how we would do this. So I'm going to slide this up here for a second. Right? So to solve without the log base button. So those are like those chunkier calculators. Some of you guys might be in this boat, all right? What you would do is we would say, okay, well, log base 3 of 40, kind of set it equal to our generic x. And then to get rid of the log, we have to exponentiate. So do 3 raised to the left, 3 raised to the right. All right, see you later. This is 40 equals 3 to what power? So the same thing we were looking at up here. But now I want to use our log properties. One of our log properties, right, is the fact that if I take the log of both sides, I can take this x and I can drop it out front. So I know you might be thinking we were just in log, but just go with me for a second. We'll go quick. So we're going to take the log of the left-hand side, log of 40, take the log of the right-hand side. So I'm just using common log at this point. I can now take that x, drop it out front. So this becomes x times log of 3. Over here, I just get log of 40. So the reason I use common log is because everybody has the common log button on the calculator. And now last thing, this is just x times some number. So get rid of that number by dividing both sides by it. So what that means is the value of that log ends up being this little quotient right here. If I go to my calculator right now, so I'll bring it back into view, and I use the common log button, so the log button on the front of my calculator. If I do log of 40, and then I divide it by log of 3, there's that exact same answer, all right? So there's that 3.357, blah, 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 right? So what does that mean? Well, think about where the question started. The question started at log base 3 of 40. Look at where it finished. We said that that's equal to log of 40 divided by log of 3. So what this is called, it's called the change of base formula. So that if you have a base other than 10, but you don't have that nice log base button, all you're really doing is the log of the number in the parenthesis divided by the log that is the base itself. So let's write down that rule, all right? It's called the change of base rule. Okay. So log base b of x is equal to log of x divided by the log of whatever that base b is. So even if you're like, but I have a fancy calculator, I don't need that, it still can be useful, all right? Some of it was just sheer practice. I wanted to make sure, like, are we understanding how to do it on the calculator? So the practice piece of it, you know, if I say, all right, let's evaluate log base 3 of 4, right? Depending on how your calculator does it, if you have the log base button, go grab that, go to math. If you don't, then you would type this in as log of 4 and then over log of 3, right? So I don't care which way you do it. Just make sure that you know how to calculate it on your calculator. So like I just said, you're either going to go log of 4 and then, oops, sorry. And then divide it by log of 3. Or you're going to go to math log base, and then you're going to type in the base of 3 and then type in the 4 here. Either way, you should have about 1.26, we'll say. Nearest hundredth sounds good, right? And then same type of thing. If you do like log base 6 of 80, you know, same idea. Type it in however you prefer. Right. Oops, I rounded and then I put the decimals. You should have about 2.44 or 2.45, which hopefully should make sense, right? Because if you think of powers of 6, 6 to the second power is 36. 6 to the third power, holy moly, what is 6 to the third power? I think 216. It is 216. So 80 is in between there, which is why our exponent of 2.45 would be in between, you know, the 2 and the 3, all right? Okay, last detail. We have to talk about domain. Domain is what are all the x values, right, that you're allowed to plug in. So if we think about the very first day, we actually graphed logarithms. So log base 3 of x, or I think we did log base 2 of x or something. Right? If I think about what this looks like, you can now go in your calculator and graph it now that you know how to type this in. So if you go into your y equals, I'm going to get rid of whatever I had in there. Oops, sorry, I got a little glare there. And I can go math, log base, and I can do a base of 3 and then put an x here. Right? So I'm going to zoom in a little, and I want you to try it. So just zoom 6 it. Zoom 6 should give you a decent window here. All right. Now, what it does look like, it looks like it starts here and then goes on. You have to know enough about the graph to know it doesn't start there and then go up and over. It keeps running down the side there because the graph has a vertical asymptote. So I want you to remind yourself of a couple of things. I'm going to zoom back out a little bit. So there's a vertical asymptote at x equals 0. And that means that the domain, the graph only exists over here where all the values are positive x values, all right? So the domain for logs, right, are positive x values only, all right? And as a little side note, the base needs to be positive too. If you right now take the log of something negative on your calculator, it's going to give you error. So the good thing is your calculator knows what the domain is. So go ahead and try it. All right. It's going to give you error, no real answers. It'll shut you down real quick. All right. So you won't make that mistake. So what does that mean for us though, in terms of like what type of questions you'll see? Well, if I ask you to find the domain, I might give you something really simple, like find the domain of log of x. All right. Well, if all it is just x all by itself, then the domain, right, would just simply be from 0 to infinity because it's just all the positive numbers. What if I ask you, though, to find the domain of log of x plus 5? All right. Well, what I want to think of in that case is this expression has to be positive numbers. And when we say it has to be positive numbers, what we're really saying is that this thing needs to be greater than 0. So what the idea is you're going to set the inside part, right, to be greater than 0. So in this case, take the x plus 5, set it to be greater than 0, subtract 5 over. There's your domain right there. That would be your domain in inequality form. If you want to write the domain in interval notation, then we would just say it goes from -5 to infinity. Because think about what that is. You're shifting the graph left 5. So if I take this graph and I shift it left 5, it's going to exist everywhere from -5 on to infinity.